According to recent industry estimates, more than 70% of consumers are saying that they are overwhelmed by product choice online. Fewer than 25% fully trust the current recommendation systems. This is creating a major opportunity for agentic commerce platforms that can deliver personalized, clinically validated, and context-aware buying experiences. My name is Paul Nashawaty. I'm the practice lead and principal analyst for the AppDev practice, and I'm joined by Konstantin from Haut.AI. Konstantin, how you doing?
I'm good. Hi, Paul. Thank you.
Welcome to the podcast today. Do you want to introduce yourself and introduce Haut?
Yeah, absolutely. I'm very happy to be in this podcast. Thank you for the invitation. So I'm Konstantin. I'm CTO and co-founder at Haut.AI. So at Haut.AI, what we do, we skin intelligence infrastructure for measuring and reasoning over human skin. So we provide AI tool set for measuring skin using images from phones or specialized devices like VZR, which is high resolution cameras. And also we provide engine for reasoning, so to understand what's happening with your skin, and provide recommendations. So what's the best product fit your skin, whether it is in skincare, cosmetics, or it's dermatology.
Well, Konstantin, I'm really excited to have you on. Prior to being an analyst, I worked at a startup that did, we called it recommendations or search 2.0 or recommendations 2.0. This is so much more than that. So it's so exciting to be on this, have you on and talk about what the world of AI and agentic kind of brings to the conversation here. But as AI is really reshaping the digital commerce space, the next wave of innovation is moving beyond simple recommendations towards agentic experiences that really do help with guiding, validating, personalized purchasing decisions at real time. We used to call this the Amazon effect, right? Whenever you bought something, you get something that recommended to you. But this is changing significantly. So what we're here to talk about is how to explore the clinically grounded AI marketplace integration and consumer trust as a conversion for redefining future retail infrastructure. So, Konstantin, I want to jump right in. Because we're talking about this in the context of, we're on the AppDevANGLE podcast. There's a lot going on with tech stacks. There's a lot going on with AI, the marketplace integrations, the consumer trust. It's a big part of it. When we look at the industry and how it talks about agentic commerce, what separates the truly agentic experiences from traditional recommendation engines? And are consumers really changing behaviors based on these AI-driven interactions? Are they really doing it, or is it something that's just kind of hype right now?
Sure. Let me start from the what's the real difference between classical recommendation engines and agentic. So let's start from the recommendation engines. What is classical recommendation engine? Usually a recommendation engine works the following way. You map inputs into products that you recommend. So this mapping has correlation nature, which is statistically derived from training data. And the major problem here is when you recommend using such system, you can explain why this product works, because in the field where we are, it's very important to ensure that the product we recommend actually has good fit for your skin, actually works. So when it comes to skincare or dermatology, we deal with biology. So in biology, what is important is to understand how ingredients interacts with some specific biological pathways, biological mechanisms. And when we say, let's say, niacinamide ingredient, which is B3 vitamin, so if we establish from training data correlation about this ingredient, we can say, okay, it correlates with brightening of skin. But it doesn't say about why and in which concentration, how it interacts with some other ingredients, etc. Because biologically, if we go to biological reasoning, we can say, okay, it inhibits some specific biological mechanism, which is called chromosome transfer. So it works very well, and the concentration 2 to 5%. But if it comes above 10%, it might cause irritations. So there is a lot of this, biological causal reasoning behind, which is not incorporated in correlation-based statistical recommendation engine. So if we, and the problem with such system also is what is very important to highlight. We can push the argument further and say, okay, but we can train this recommendation system using more data, enormous data set. Can we improve it to make it really excellent? And the answer actually is rooted in fundamentally how fundamentally this works. Because if you push more and more data, basically you end up with finding a lot of false correlation between data, between different facts. So I give you some very simple example. So let's say you would like to find the correlation between ice cream sales in US and drowning deaths in US, and the correlation will be very high actually. And you can establish, based on such correlation system, you can establish a fact that ice cream sales rise actually causes drowning deaths. But there's no reason behind this, because the real reason, because people buy more ice creams during summer, and people also like swim during summer more, swimming during summer. This is false correlation we can establish, and such kind of correlation depends, we can find a lot, and they will cause a hallucination of the system, of your recommendation system. So and therefore it's important to especially in biological clinical systems, it's very important to come to have the system which is reasoning based. It comes to please go ahead.
No, Konstantin, that makes a lot of sense. I think the question, like the thing that kind of comes to my mind is, we're having this discussion about this use case, this large data set. One would ask, well, why is this on the AppDevANGLE? Well, in my mind, we have these new modernized applications that are driven by the LLMs, the backend systems, all the data sets that you're talking about. There's a lot to consider, a lot to think about. And when you look at the marketplace interaction, so from an end user perspective, this skincare is a very complex thing. There's a lot of products out there. There's a lot of biological pieces that kind of go along with it, and there's a lot of data, right? So when we talk about the skin chat application or interaction that you have on the marketplace, it operates as a standalone consumer test that directly is tied to direct-to-consumer platforms, right? And this is giving all of the stuff that we just kind of talked about, all the science, all the logic, all the data that is driven behind the scenes. It gives the end user the ability to pick and choose what the right product is for their needs. So when we look at that, what advantage does this provide, and what are the limitations or strategic risks that come with providing these types of tools to the end user?
First of all, Skin.Chat, it's we as a company, we are a B2B company, so we provide technology to our customers, and we work in two areas: commerce, which is where Skin.Chat is located, and clinical studies. We have solutions for supporting clinical studies for skincare companies and pharmaceutical companies. So when we talk about Skin.Chat, Skin.Chat is based on the technology, the core technology, which is we call it the skin intelligence layer, which is exactly the reasoning layer which ensure the best recommendation for consumers of skincare products or dermatology products. And this skin intelligence layer it basically consists of several steps. So the first step is measurements. So we measure skin. So when you as a consumer you come to skin chart or some technology which is enabled by our to some products enabled by our technology, you first of all you will be asked to take a picture of your skin. For example, to make a picture of your face, or if you would like to analyze your face or body areas of skin to understand what's happening with your skin. So we measure. Second, based on these measurements, we reason. So we reason in order to understand what state of the skin you have now. So we actually establish a state, and based on the skin state, for example, we can recognize that you have compromised barrier function. So based on this conclusion, we can do recommendations. This is a chain of reasoning. So, and we do recommendations. You apply a product, you can come back, take another measurements, and it will work like feedback control, so feedback loop. So we can aggregate history, and based on this history, we can actually fine-tune reasoning and recommendations over your skin.
Yeah, that makes sense. I get that, but you emphasize that clinical validating the clinical data is the foundation for the recommendations. I totally understand that because you have the grounding of the information. I do that from a data set myself when it comes to the research. But what does the validation process actually look like? How do you create a trust compared systems trained on scraped internet data versus generalized LLM outputs? Because LLMs can hallucinate and provide information. They just make stuff up half the time. How do you validate that to make sure it's accurate?
The question not only in the validation, because validation is a very critical part, but without validation you can't actually push the system to production. So before validation, we have to ensure that the system is designed correctly. And every step that I describe you in measurements, reasoning, and recommendation is designed such a way so there is a specific reasoning mechanism and specific logic which ensure that the system works predictable. For example, for the reasoning part, we use knowledge graph, which is based on the causal dependencies. So it consists of the causal dependencies of biological mechanisms. So a knowledge graph already incorporated information about how specific ingredients impact specific biological mechanism, which might happen because you have some problem, you have a condition of some specific condition of your skin, and it means that there is some underlying biological mechanism. And in this graph, you can traverse the graph and understand how these specific ingredients might help you, or probably might deteriorate your state. So this is foundation. Then, when the system is established and trained, we need to validate it. And clinical validation is very important. So we usually start from the benchmarking the system. So we benchmark the system against some internal previous versions we have. Also, we benchmark the system against some publicly available models, so to understand where we are. And thirdly, we have our own dermatologists, and also we have many contractors, dermatologists, who help us to label, to analyze images. So they look at the images we have our data set, and they label these images. For example, these images are skin patches. So we ask them, okay, what the quality of the image? What kind of do you see this condition? Do you see this, for example, redness, erythema? Do you see hyperpigmentation, whatever? So they label these images, and we use this data set in order to benchmark our system to understand where we are.
Yeah, that makes sense on the grounding of the data. I totally that clarifies that piece. Let's talk about adoption as we're looking ahead into 2026. This has both enterprise and consumer application use cases for this technology. It definitely has uses around areas. How do those experiences differ, right, in practice? Where do you see the strongest adoption today? You mentioned that you're a business-to-business kind of model, but but this definitely can be used at the consumer level as well. What are your thoughts around that?
Yes, we focus in mostly on the B2B. So, but of course, B2C component is part of this model, because eventually, ultimately, our technology is used for consumers. And but the model is straightforward. So we provide technology to enterprises, but at the same time, we ensure that technology works on consumers. To ensure that it works on consumers, again, it comes down to validation. And one of the key part of this, again, if you're coming back to validation, one of the very important part of this validation also to conduct clinical studies, clinical trials of our model. So by third party, so in order to ensure that it works at scale on real people. And this, I think, is the main difference. So we provide this technology to enterprises, but we ensure that it works on real consumers.
Yeah, that makes sense. All right, so we're coming to the end here, but before we wrap up, Konstantin, what if the listeners want to learn more about what you and the team are doing here? Where should they go to learn more?
So first of all, you can go to our website, Haut.AI, or you can try our system, skin.chat, which is very simple. Skin.chat. It's our, for demonstration purposes, our skin chat system, which is integrated with Amazon shop marketplace. And also follow us on LinkedIn as well. We publish a lot.
Pleasure talking with you today. Thank you for being on the AppDevANGLE. It's interesting to see these use cases in action and see how these things are evolving over time. It's really, really powerful. But thanks for being on today.
Thanks so much, Paul.
Yeah. And thank you for watching, for all of you who've tuned in. We do appreciate you being part of the AppDevANGLE community. But for now, that wraps up this episode. But we'll be back next Wednesday with another conversation diving into the tools, trends, and talents shaping the future of application development. So whether you're deploying at the edge, building with AI, or modernizing your cloud stack, we've got you covered. Be sure to follow us on social if you have any thoughts, questions, or just want to connect. Until next time, stay curious and stay building.